Hi! Today in class we learned about the quotient rule, or the quotient rule of exponents specifically. So we're going to go over what we did in class. First you came in and worked on bell work. Yesterday we learned about the product rule, where if the base is the same and product means multiply, and you're multiplying, then you can just add 4 plus 7. So x to the power of 4 plus 7 is 11. Then at the end of class, we kind of did this extend your thinking. Well, if we know we're adding something plus 2 equals 8, what plus 2 equals 8? Well, you could do it in your head, you could do it in a calculator, but really it's 8 minus 2 is 6. So B equals 6. Ooh, those two look similar to each other, huh? And then solve this equation. 13 equals negative 2z plus 5. I'm going to do this up here just because I don't have a lot of space down there, but 13 equals negative 2z plus 5. This is a two-step equation. I like to draw a wall first. That wall just reminds me that whatever I do on one side, I need to do on the other. The goal is to get z by itself. So first I need to get rid of whatever's not directly attached to z. So right now, that negative 2 is directly attached to z, so I can't get rid of it yet. It's kind of stuck there. But I can get rid of the thing that's a little bit further away, which is the 5. So the opposite of a plus 5 is a minus 5. And if I do it on one side of my equal sign, I have to do it on the other side of my equal sign also. Same exact thing, minus 5. 13 minus 5, well 13, 12, 11, 10, 9, 8 equals 5 minus 5 is 0. I like to just cross it off. Some people like to write 0. Cool. But I do still have this negative 2z, so I'm going to write it down. Negative 2z. Now negative 2 is squished together with a z. So whenever a number and a letter are squished together, there's an invisible multiplication sign. So the opposite of multiply is divide. So to get rid of it, I do divided by negative 2. Divided by negative 2. And then 8 divided by negative 2 is negative 4. So z equals negative 4. So that was our bell work. And then I had you guys open up, I think, to page 8 in your notebook and wrote down the goal. I can simplify exponents using the quotient rule. And then we did some group work. So here, when you're done, raise your hand so I can check page 8 before you move on to page 9. You're doing it with me right now, so we'll totally be able to check. Here is our notebook, page 9, or sorry, I apologize, page 8. I can simplify exponents using the quotient rule. Go ahead and write that down. Okay, well remember product that we did yesterday, product meant multiply. Quotient means divide. So here, what does x to the power 5 divided by x to the power of 2 mean? And that, it looks like a fraction. Well, a fraction is really the same as just divide, right? If you have a fraction, 1 over 2, it really means 1 divided by 2. We just leave it as a fraction, 1 over 2. So I'm going to write it out. Remember, x to the 5th means x times x times x times x times x, so there's 5 of them. So 1, 2, 3, 4, 5. And then all of that over, and you'll see why I like it as a fraction instead of a divide symbol in just a minute. X times x, because there's 2 x's. Now, I wrote it in the front of the fraction sign. You could write it back here. Usually we write it right in the middle, but you'll see in just a minute why I wrote it on the side. When we're dividing, when we have a fraction, anything that's exactly the same on the top and the bottom, those just divide to the number 1. So for example, let's say I had, instead of 1 divided by 2, I have 2 divided by 2. Well, 2 divided by 2 is just 1. So x divided by x is just a 1. X divided by x again, that's just a 1. And then I just still have those 3 left, x times x times x. Okay, well what's 1 times 1 times all these x's? It's just 1. 1 times anything is just that thing. So really all we have is just those 3 x's. I didn't even have to write those 1s. And then we already know x times x times x, there's 3 x's, so that equals x to the power of 3. So then it's going to ask, well, what is something quicker we could have done instead of all that work? writing it all out, seeing what is on top and bottom that you can cross off. What's a faster way to simplify than that? Well, how do we relate 5 and 2 to each other? To get a 3, we subtract 5 minus 2. So we can write subtract. 5 minus 2 equals 3, and that would tell us our exponent. And that's the rule. When the base is the same, okay, so same as with the product rule, that base, this has to be the same thing, because that's what allows it to cross off top and bottom, is when it's the same thing. Then all you do is just shortcut, take the exponents and subtract them. So here, x, the base is the same, 5 minus 3, that's 2. Quick and easy. Excuse me. Okay, y and y, the base is the same. This one has a 4, and this one has nothing. But remember, if it was going to be a 0, then there would literally be nothing written down here. So there's at least one y. If it was a 2y, there would already be a 2 here. So when there's nothing written, there's an invisible 1. 4 minus 1 is 3. Okay, a complicated one. So this one, the number 15 does not have an exponent. So we just kind of push it off to the side over here. Let's deal with it later. And the number 3 does not have an exponent. So we just kind of push it off to the side here. Notice how I left it as a fraction, just like they wrote it. But like, we're not going to deal with it right now. Let's just do the z's. Oh, z and z, that's the same. 7 minus 4, so z to the power of 3, because 7 minus 4 is 3. Now, we're not allowed to actually like totally ignore them. So we can just divide. What is 15 divided by 3? It's 5. So that's how this one simplifies. And our last one, the base is not the same. This 4 does have an exponent. But this 3 is not the same as 4. So even though they do have exponents, we can't simplify it because the base is not the same. So then I told you guys, like, hey, I want to make sure you understand this because this is kind of a difficult concept. And then you're like, yeah, we totally get it, 100%. So then you moved on to page 9 and did some practice. Write the expanded version. Okay, same as yesterday. The reason I have you write the expanded version is so that you can be grateful for this quotient rule. Yeah. So x to the 4th, 1, 2, 3, 4. And then x to the 2, 1, 2. And I can cross off, and look at that. It's x times x, which just equals x squared. Could have just subtracted. Y to the 5th, 1, 2, 3, 4, 5. Just a single y on the bottom. Those two cross off. And there's 4 y's left, y to the 4. Okay? Feel free to pause the video at any point. I'm just whipping through this, but you can slow it down. Write down as you need it. 4 to the 7. That means, because look, the 4 has an exponent. So that means there's 7 of these. 1, 2, 3, 4, 5, 6, 7. And then there's just like a plain old 4 on the bottom. And we're lucky because 4 and 4 are the same thing. We can cross that off. And now we have 4 to the 6. Now with questions like this, what we're doing in class is simplifying. But I've seen every now and then them just say, hey, like, what's the value of this? That means literally, like, what is 4 to the power of 6? Type in your calculator, get an actual number, right? But when we're simplifying exponents, when we're simplifying to a single exponent, it wants it to look like that. Okay, the base is the same, so I can do this over and over again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So I can cross those off. And 8 minus 2 is 6. 1, 2, 3, 4, 5, 6 equals 5 to the power of 6. All right. Ooh, we got some numbers in front. 21 does not have an exponent, so we just, like, we're going to ignore it for now. 7 does not have an exponent, so we're just going to ignore it for now. Notice again how I wrote it with the divide symbol, because that's like what it showed. But I'm just kind of like, meh. Okay, x to the power of 8. 1, 2, 3, 4, 5, 6, 7, 8. On the bottom, there's 3 of them. 1, 2, 3. Now we can cross some stuff off. 1, 2, 3 of them got crossed off. 8 minus 3 is 5. 1, 2, 3, 4, 5. So we have x to the power of 5. But I can't actually like totally ignore 21 and 7. So we do what it says. It says divide, right? Fraction symbol means divide. 21 divided by 7 equals 3. So that's just a number in front. Okay, this one, I'm not going to write out the expanded version because negative exponents are different, but let's just use our trick. We know the base is the same, check mark. So we subtract the exponents. 6 minus, this exponent is a -3. Minus a negative is the same as just adding. So this is y to the power of 9. We're going to learn in a couple days why that's true. But for now, trust the process, right? That's what they think. Okay, looks like we've just got a couple more. Okay, plain old numbers. 21 does not have an exponent. 4 does not have an exponent. So I'm just going to ignore them for the moment. 11 minus 6, we're simplifying. We're not going to write it all out now. 11 minus 6 is 5. Okay, oh, this one. I'm going to break this up. First, let's deal with those x's. That was a 2 right there. 3 minus 2, that's just a plain old x. Now let's deal with the y's. 7 minus 1, that's a 6. So even though I couldn't simplify all the way to like one base and one exponent, I was able to still simplify it a lot. Okay, plain old numbers, 15 and 12. We'll ignore those for now. Y divided by y, that just becomes like multiplied by the number 1, which you remember means we can totally ignore it. But for now, I'll write it to show you. And then z to the 5th divided by z to the 3rd. 5 minus 3 is 2. Z to the 2. Okay, well, this 5 divided by 12 we can't actually ignore, but 5 doesn't divide nicely into 12, so I leave it as I'll show you, I'm still going to divide, but when you divide, I'm simplifying. So 15 divided by 3 is 5, 12 divided by 3 is 4, and then times 1, well, times 1 is just times itself, so it's really times z squared, because we can ignore that one. So 5 divided by 4, yes, you could write that as a decimal. The reason I leave it as a fraction like this is that sometimes it's like a repeating decimal or it's a really long decimal, and it didn't give us any directions about rounding, so I don't know what to round it to, so we leave it as a fraction. Now x, y, z, a, b, c, literally none of those are the same letter, so there's nothing we could simplify, so we just leave it like that. Okay, so after you worked with your team, then it was time for an exit ticket, and you guys know how to do all of these things, but we'll go over them. The base is the same, yeah, and then there's an invisible 1 right there. 7 minus 1 is 6, x to the power of 6. Explain in complete sentences what is the quotient rule of exponents. Quotient means divide. When the bases are the same and you're dividing two expressions, then you can just subtract the exponents. All right, and then extend your thinking. Oh my goodness, this was a challenging one. What value of b makes this equation true? Well, we have to subtract. 5 minus something equals 9? Like 5 minus 1 is 4, 5 minus 2 is 3, 5 minus 3 is 2, 5 minus 4 is 1, 5 minus 5 is 0. So we've just checked all of the numbers from 5 down to 0, which means we have to go to the negatives. 5 minus -1, right? Minus a negative is the same as just adding. So our answer has to be a negative of some kind. So 5 plus 1 is 6. 5 plus 2 is 7. 5 plus 3 is 8. 5 plus 4 is 9. Now we know it's not actually plus, it's actually subtracting a -4. Wow, that was a challenge question right there. Okay, there you go. That is what we learned about today. Have a great day.